This is today's lesson found on page 18 in your packets. This is 4.3, Graphing Linear Equations, page 18. Relationships between two variables can be shown in 4 different ways. We've seen all 4 of these so far. The word way, like the Buffany Middle School question that we did today in class. The table of values, where you're getting an x and a y and getting ordered pairs. What is the relationship of y divided by x equaling k? Proportional. Equations, y equals kx, or y equals mx plus b, and on the graph. So we're going to be graphing these relationships. We did this a little bit last year. We're going to extend and add on to that. In a linear relationship, there are infinitely many solutions. A line has infinitely many points on it. X and y vary in this relationship with that constant unit rate called slope. The solution is written as an ordered pair x, y. An ordered pair is a solution of an equation if it makes the equation true when you substitute in the given x value and the y value. So which ordered pair is a solution of y equals 2x minus 3? So you have to replace those letters, x and y, with the x and y of the point that's given. So I'm going to do this mentally out loud, speak through this example. So A, 0 is x, y is 3. So does 3 equal 2 times 0, which is 0, minus 3? Does 3 equal negative 3? No, A is not the choice. B, on to B. When x is 5, 2 times 5, 2x, 10, take away 3, do I get y equaling 7? Yes, 7 is 10 take away 3. B is my choice, so I don't have to keep going now. The point 5, 7 is a solution to the equation, the linear equation, y equals 2x minus 3. Example 2. Which point lies on the graph? Well, if it lies on the graph, it is also one of the solutions. And I'm sorry about the graininess of this video here. A little trouble with the bulb in the machine. Anyway, F, 0, negative 5. So same thing, y equals negative 3x plus 5. So when I put in 0, negative 3 times 0 is 0, plus 5 I get 5. Not negative 5, so it's not F. G, when I put in negative 1 and 2, negative 1 for x, so negative 3 times negative 1 is positive 3 plus 5 is 8. Oh, that's not 2, so G is not correct. H, negative 3 times 3, x, equals negative 9. Negative 9 plus 5 does equal negative 4. H is the correct point that lies on the graph, which also means it is a solution to the equation y equals negative 3x plus 5. Graphing linear relationships given a table. For examples 3 through 6, find the missing values. You're solving the equation when they give you the x for each table and graph each equation on the same grid. So 3 and 4 are going to be on this piece of Cartesian plane here, the coordinate grid that you see here. So number 3, when x is 1, so 1 plus 3, y is 4. When x is 0, 0 plus 3 gives me 3. When x is negative 1 plus 3 gives me 2. Easy equation to solve. Number 4, y equals 3x minus 4. So when x is 0, 3 times 0, I get negative 4. When x is 1, 3 minus 4 is negative 1. When x is 2, 3 times 2 is 6. Take away 4, I get 2. Now I'm going to graph these points. And because I'm doing it on a smart board, hopefully they'll graph nicely. 1, 4. 1, 4, my first point here in number 3. So x is 1, y is 4. Make sure you're plotting x first. 0, 3. And negative 1, 2. They should line up in a line. Yes, this looks pretty linear. So I'm going to take a ruler, you're going to take a ruler, and carefully extend this line. I know this slope is up 1 and over 1, so I should be making sure that the line that I'm drawing is going through the graph paper correctly. Up one box, over one box. Yes, 1/1 is my slope. Now, to finish this, I'm going to write the linear equation, y equals x plus 3, on this line. Usually above it or somewhere around it. Get that equation on there. Okay, the example number 4, 0, -4. Plotting that point, 1, -1. And 2, 2. And from what we've done with slope, yes, I know that I'm going up 3 and over 1, up 3 and over 1. So when I take my ruler, I sketch out, or I look out, at least up 3 and over 1. So I try to line my ruler up with the points, sight out, up 3 and over 1. So I know it's also going to go through the point 3, 5. And I try to get my ruler so that it goes through 3, 5. Sight out a point or two. Line up carefully, because if you're going to graph this correctly, you don't want it to go through points which are not solutions to the equation. You have to be very careful. So this is the line y equals 3x minus 4. Next page. Okay, yes, this is still part of the, for examples 3 through 6. So number 5 and number 6 we are doing. X plus y equals 6. Well, I like to solve it for y equals. So I'm going to subtract x from both sides, and I get y equals -x plus 6. That's just me. Don't have to do that. You can figure out what x plus y is. Oh, this is a 1 here. So when x is 1, I know 1 plus 5 is 6. When y is 3, when y equals 3, what number does x have to be to get, y equaling 3? So you're substituting in, okay, y is 3 equals -x plus 6. Well, that must be positive 3, right? 3, put it in there. So negative x, the opposite of x, right? So I'm going to take the opposite of that and call it 3. So yes, probably was easier to do it this way. 3 plus 3 equals 6. Yes, I know that. And a -1, maybe not solving it for y would have been easier this time. I just like solving it for y. So -1 plus what y will give me 6. It's got to be 7. -1 plus 7 will give me 6. So that's the answers to 5. Number 6, y equals 7 minus x. Well, if y is 0, 7 minus, that must be 7. Right? 7 minus 7 equals 0. If x is 5, if x is 5, 7 take away 5, well, y's got to be 2. If x is -1, 7 minus -1, so I'm substituting in the value x, I get 8. Y has to be 8. So now I'm going to plot these points. 1, 5, 3, 3, -1, 7. And yes, I already did draw my coordinate axes on my graph paper, and I labeled 4 in all directions. Being very careful that you label x and y. It's hard to draw with a ruler. You should be using a ruler, as we talked in class. Please use a ruler. Put your coordinate axes, x and y, on here. Number 4 in all directions. Label your x, label your y. So you may need to take a moment and do that. And then plot these 3 points for number 5 and the 3 points for number 6. So you may have to stop and pause for a moment. That's okay. I'm going to keep going. 7, 0 is the point for number 6. 5, when x is 5, y is 2. And when x is -1, y is 8. Both of these have a negative slope. When I solved it for y, number 5, I got -x plus 6. and number 6 is negative x plus 7. They have the same slope. I don't know if you noticed that. This is negative x, and this is negative x. So my slope for both of these equations is negative 1 over 1. And yes, you can see that the points are going down across the graph paper. Watch what happens to lines, linear equations that have the same slope, the same rate of change. So again, cite out your points carefully. Make sure that you're drawing that line so that it's going down 1 and over 1 using my slope. Then you can probably see that lines, yes, that have that same rate of change, that same slope, are parallel. So that's a key thing to know. Same slope lines, linear equations, will be parallel lines. Last thing that I have to do is I have to write the equation on the line. So number 6, y equals 7 minus x. That's that top line here. And number 5, the original equation, not the one I changed it to, y equals negative x plus 6. X plus y equals 6, the original given equation. And it's really hard to write it in here, so I'm going to put it off to the side here. X plus y equals 6. I'm going to label that line down here. And the last couple examples here, complete the table for each equation. Y equals 7 plus x. Well, when x is negative 4, 7 and negative 4 makes 3. When y is 5, 5 is equal to 7 and negative 2 has to be the x. When y is negative 1 is 7 plus negative 8. I'm going to leave 8 and 9 and 10 for you to do on your own, and we will check that as part of our video notes check. That's it for today.